So this video is all about curve fitting. So you've taken a look at a lot of functions, linear functions, quadratic, cubic, reciprocal, absolute value functions. But these functions can be used to model things in the real world. And if you take some observations of something happening in the real world, you can put those on a graph, and then you can create an equation to describe that thing in the real world. So I'm going to use our ClassPad for this. So if you don't have your ClassPad with you, don't watch this video. Pause it, do something else, get your ClassPad. So here's a classic sort of question. A ball is thrown into the air, observations are taken. Using technology, find a function that fits the flight of the ball. So after 0 seconds, the height of the ball is 0 because it hasn't been thrown yet. After 0.5 seconds, the height of the ball is 0.6. After 1 second, the height of the ball is 9, and so on and so on. So I'm going to get my ClassPad out, and then I'm going to run through this. Okay, so here's my ClassPad. We can see a ClassPad here. It looks a little different to yours probably because it's in color, but it doesn't matter. We're going to go into our spreadsheet mode. Now what I'm going to do is the seconds, that's going to go in column A, and the height of the ball, that's going to go in column B. So 0, 0.5, 1. You don't need to watch me type all this in. Alright, so I've typed everything in there. Now what we're going to do is put that on a scatter plot using our ClassPad. So here, my little down arrow, I can choose a bunch of different graphs. I'm going to choose this scatter plot. Now you can see I can't really see much in my scatter plot, but what I need to do is just change I just zoom out a bit. Or we can just zoom to fit. So now that I've got all my values in there, I'll just select them, just clicking and dragging. So I've selected them all. And then using this arrow here, I'm going to choose the correct graph. We want a scatter plot because we're going to put those points onto a scatter plot. We get this nice little thing here. Now, you should be looking at that and you should be thinking, oh, that looks like a little curved quadratic. So we can now fit a curve. We can come up with an equation for this. So there's all sorts here. If I go through this, there's a linear equation, there's x squared, there's an x cubed, x to the 4, x to the 5. There's an exponential equation, which you haven't done a lot of. There's a similar thing, like a growth curve. There's a log curve, a logarithmic curve, which you haven't done a lot of yet. And there's also a sine curve here. So we're going to fit it to those different curves. It looks pretty obvious that this is like a quadratic, so I'm going to fit it to the quadratic. Okay, and you can see it doesn't fit very well in terms of our quadratic because it's a bit pointy there. It could be that whoever was taking these values didn't do a very good job of recording it. In my case, I made up those values, so I didn't do a very good job of making them up. Now, what we have is a quadratic regression. That's what this is called. We know that the A value is negative 3.84. We know that the B value is 15.35. And we know that the C value is negative 2.19. So I can take my pen over here, and I'm going to just write that down. Oops. Okay, a little bit of trouble there. Let's try that again. So f of x equals ax squared plus bx plus c. And in this particular case, the a value is negative 3.84 equals negative 3.84x squared plus the b value is 15.36 x plus minus 2.19. So what we have now, and this is the whole game that we're playing here, what we have is a function, f of x equals negative 3.84x squared plus 15.36x minus 2.19, a function that describes the path of that ball. And we can use that function to find out when the ball is at its highest point, or we can use that function to calculate when it will touch the ground, or all sorts of different things that you can usually do with a function once you've got it. Okay, that's fitting a curve using your ClassPad. Make sure that you're comfortable with the steps there. You'll be using them to fit a whole bunch of different curves.